Rationalising the denominator. What that really means is changing a fraction with a surd on the bottom, on the denominator here, into a fraction with a rational number on the bottom. That would be the preferred format by mathematicians, scientists and engineers when using their calculations. So what we're going to do over this clip, we're going to be looking at the simple rationalising the denominator all the way through to looking at something a bit more complicated where we'd be using conjugate surds to solve that type of question there. Okay, so let's start off with the first one that we have here. So I'm looking at 1 over root 2 and I have to rationalise the denominator. What I'm going to do here is I'm going to look at the surd that's on the bottom. I can see it's a root 2, and what I'm going to do is, to sort that out, I'm going to multiply the top by root 2, and what I'll do is I'll multiply the bottom by root 2. Okay. So if I multiply that out, what that should give me is 1 root 2 on the top, and on the bottom I've got root 2 times root 2, which should give me root 4, and if I simplify the bottom, the denominator, what that gives me is root 2 over 2, and that would be the denominator rationalised. What I see is I see that very similar to working with fractions. If I look at fractions and I look at a fraction, if I start off with a half, and if I multiply a half on the top by 2 and on the bottom by 2, that would give me 1 times 2, it's going to be 2, 2 times 2 gives me 4. Okay? 2 over 4 is the same as a half, but it's just in a different form. And all I've done there is I've multiplied the top and bottom by 2. So if I look at what that part is there, 2 over 2 is just equal to 1. So really, all I'm doing is I'm multiplying it by 1, and I'm actually changing it. I'm just changing it into another form. That would be the same if I think about 3/4. So if I go with 3/4, and what I can do with 3/4, what about just multiplying the top by 4 and the bottom by 4? That will give me an answer of 3 times 4 will be 12, and 4 times 4 is 16, and again 12 over 16 is the same as 3/4, and all I've really done is I've multiplied by 4 over 4, which again is just equal to 1. Okay, so I'm just multiplying by 1. With surds, it's just a little bit different. What I'm multiplying by is, in the first example there, would be root 2 over root 2. And any number divided by itself is just going to be equal to 1. So really, all I'm doing is multiplying all of these out by 1. Okay, let's get back to the part B. We'll do the second part here. Okay, what we can do, if you get the idea how to do this, what I would do is I would freeze the video. I would work through the questions and see if you get the answer, and just play it again and you'll see the answer when I do it. Okay, I've got root 3 on the bottom. What I'm going to do is I'm going to multiply the top and the bottom by root 3. What I should get on the top is root 3. Root 3 times root 3 gives me root 9, which should give me an answer of root 3 over 3. Root 5 on the bottom, I'll multiply the top by root 5, multiply the bottom by root 5, and what that should give me is root 5 on the top and root 25 on the bottom, and just simplifying out the bottom there should give me 5. So that's root 5 over 5. D, I've got a 6 on the top. What I'll do is I'll multiply by root 3, top and bottom. 6 times root 3 should give me 6 root 3 on the top. Root 3 times root 3 will give me root 9. If I work out what root 9 is, that should just give me 3 on the bottom. Now what I've got there is I've got a 6 on the top and a 3 on the bottom, and just like we would deal with normal fractions, divide the top and bottom by 3. So that should give me 2 root 3 on the top, and 3 divided by 3 gives me 1. And quite simply, that would just come down to 2 root 3. Also, when you're doing some of this work here, you can use your calculator to work out some of the answers. If I convert my calculator into fraction mode, what I can do is, if I try the first question, so I'll have a 1 on the top, I'll have a root 2 on the bottom, and what that should, if I press the equals, what it'll do is it will just work it out for me immediately. So that's just changed it straight into the rationalised form, the rationalising the denominator. So you can check your calculations through by using the calculator. Right, let's move on, and we'll move reasonably quickly. What I have here is, I've got some further numbers, and most of these have a numerator that's greater than 1. So we'll work through that, and we'll just have to simplify down towards the end. Root 5 on the bottom, times the top by root 5, times the bottom by root 5. That should give me 10 root 5, and on the bottom I've got root 5 times root 5, which should give me root 25. That'll be 10 root 5 on the top and 5 on the bottom. So from there I can divide the top and bottom by 5. What that should give me is 2 root 5. I've got root 3 on the bottom, so I'm going to multiply by root 3, top and bottom. That should give me 2 root 3. On the bottom, root 9. That'll give me 2 root 3 all over 3. I can't simplify that any further, so that's that complete. Times in the top by root 5, bottom by root 5. From there I've got 3 root 5 all over root 25, which should equal 3 root 5 all over 5. H will be multiplied by root 2 on the top and by root 2 on the bottom. That should give me 20 root 2 and root 4 on the bottom. So 20 root 2 all over square root of 4 is 2. Dividing top and bottom by 2 will give me 10 root 2. Okay, we'll move on to part 3. Okay, so we're going to have 1 all over 2 root 5. So let's go ahead and we'll look at that one. So I'm going to multiply the top by root 5. I'm still looking at the root. Although I've got a 2 outside there, I'll just multiply by root 5. What that should give me is root 5 all over 2 that's there. Got the root 5 there and another root 5 there. So that's what I'm multiplying out on the bottom. Numerator, root 5, and I've got the 2, and root 5 times root 5 should give me root 25. Root 5 on the top, 2 times, that will become 5, because the square root of 25 is 5, and finally that will be a root 5 all over 10. So that's me just change that around from there. You can do some simpler working than I'm doing there, but I'm trying to show you all the steps that are involved. Root 2 on the bottom, times with root 2, times with root 2, should give me 4 root 2 on the top. I've got 5 root 2 on the bottom, all of these combined. That'll give me 4 root 2, 5 times root 4. What I'll do is I'll take the square root of 4, that'll give me 2, and that should give me 4 root 2 all over 10. From there I can divide the top and bottom by 2, that should give me 2 root 2, and on the bottom I should be left with 5. So remember, just freeze the video as I'm going along and just check your answers as you complete them. Multiply by root 2, because there's root 2 on the bottom there, so that gives me 3 root 2, that's all over 3, and I'm going to just combine these, that's going to be root 4 now, okay, root 2 times root 2, root 4, 3 over root 2, and on the bottom I've got 3 times 2 that's coming out of there, and I could have simplified down a wee bit earlier, but what I'll do is I'll just gather this together and then I'll simplify it from there. 3 on the top, 6 on the bottom, divide the top and bottom by 3, so that would be a 1. I'll just leave me with root 2. Dividing 3 into the bottom, that will just leave me with a 2, so root 2 over 2. We've got 12, I'll over 5 root 6. So let's multiply by root 6. What I've got is 12 root 6 on the top, and I have 5. I've got root 36. 12 over root 6, and I've got 5 times 6, that'll be there, because the square root of 36 is 6. That gives me 12 root 6 all over 30. What I can do is divide the top and bottom by 6, or I could have divided out here by 6. What I'll do is I'll divide these ones by 6, that'll give me 2 root 6 on the top, and 6 into 30 will give me 5. So 2 root 6 over 5. Okay. I'll move up to number 4, section 4. Okay, so what I have is 2 roots here this time. I've got root 3 over root 2. Okay, and what I'm going to do is I'm just going to work through the same way. I'm going to multiply the top by root 2 and the bottom by root 2. What that should give me is root 3 times root 2, which will be root 6 on the top. Root 2 times root 2 gives me root 4 on the bottom, and the root 4 I can work out. I can take the square root of 4, which should give me 2. So that would be root 6 over 2, simplified down. Root 2 over root 5, I'm going to multiply by the root at the bottom, so that's going to be root 5 times root 5 on the bottom and the top. That should give me root 10 on the top, and on the bottom I've got root 25. A root 25 will work out to be 5. 25 is a square number. I've got root 8 on the top and root 2 on the bottom. I could look at this the same way as we did with dividing fractions, but I'm just going to rationalise the denominator. I'm just going to work that through. So that's root 2 and root 2 that I'm going to multiply by. That'll give me root 16 on the top. And on the bottom, root 2 times root 2 is going to give me root 4. If I simplify that down, I'm looking at these numbers, they're both square numbers. So that will give me 4 on the top and 2 on the bottom. If I divide 4 by 2, that's going to give me an answer of just 2. Now looking at root 18 over root 3. Okay? And again I could have divided that down the way that I've shown in dividing surds. What we'll do is we'll just multiply by root 3, multiply the bottom by root 3, and what we'll do is we'll see how this works out. Okay? So 3 times 8 is going to be 24, 3 times 10 is going to be 30, so that's going to give me root 54 on the top. And on the bottom I've got root 3 times root 3, which should give me root 9. Okay? What I can work out here is that I've got root 54 on the top, and I've got root 9 on the bottom, so the square root of 9 will give me 3. Okay, and what we'll do next, we'll move on to rationalising the denominator number 5. Okay. Okay, so what I have here is I've got 1 over root 50. So let's just multiply by root 50. What that should give me there is it will give me 1 times 50 on the top, so that's going to give me root 50. And I know that root 50 times root 50 is just going to give me a number out that's going to come out to be 50 on the bottom. So that's going to be my answer to that one. I'm looking at the top of that one there I've got root 50, so if I remember I can simplify that down as a surd. So let's have a look at that. So I could have root 25 and root 2 all over 50. Simplifying down a bit further, that will be 5 root 2 all over 50, and I've got a 5 and a 50, divide the top and bottom by 5, that should give me root 2 over 10. what I'm going to look at here is I'm going to multiply by, let's see, we'll go for root 27 times by root 27. So what I've got on the top is 18 root 27. On the bottom I've just got the answer 27, because root 27 times root 27, as we know, will multiply out to give me just 27. What I can do then is I can divide the top and bottom to try and simplify down the fraction. So I can divide by 9 on the top and 9 on the bottom. So if I divide by 9, that will give me 2 root 27 all over 3. 9 threes will be 27. Looking at this surd here as well, I think I can simplify that down a bit further. So what I have is 2 there, that will be root 9 times root 3, and that will all be over 3. And what I can see there is that root 9 is going to work out to be a 3. That's going to be times root 3, all over 3. 2 times 3 is 6, and then I can simplify down, or I can divide the top and the bottom by 3, which leaves me with 2 root 3. What I have here is I've got 5 over root 50, so multiply top and bottom by root 50, and what that should give me is 5 root 50 on the top, and just coming out with 50 on the bottom. Simplifying that down, that would give me root 50 over 10. So I'm just dividing the top and the bottom by 5. Root 50 is a surd that I can simplify further. So that's root 25 and root 2. And that's all going to be over 10. Root 25 is going to give me 5 root 2 all over 10. And finally I can simplify down a bit more. I've got 5 and I've got 10, divide the top and bottom by 5, gives me root 2 all over 2. The final one of this type we're going to do over here. We've got 3 on the top and I've got root 20 on the bottom. I'm going to multiply by root 20, top and bottom. What I'm then going to have is I'm going to have 3 root 20 all over 20, because root 20 times root 20 will give me 20, or it'll give me root 400. Root 400 is 20. I can't seem to simplify this fraction down, but what I can do is I can do something with this surd here. What I'll do is I'll convert that into a square number and another number multiplied together. 4 times 5 gives me the 20. That's all over 20 there. 3 times the 2 times root 5 all over 20, and what I can do here is I can divide the top by 2 and the bottom by 2, it'll give me 10, so that should give me a final answer of 3 times 1 root 5 will give me 3 root 5, and on the bottom I've got 10. That should be my answer there. What I'll do is I'll just come back to another one I've just spotted. I've just seen that up at the top here. I've got for 4 part D, if I look at 54, I think I can simplify that down a bit further. So that would be root 9 and root 6 all over 3. Root 9 will simplify down to 3, 6 all over 3. And what I'll do is I'll divide the top and bottom by 3, which leaves me with root 6 on its own. Okay, I'm glad I spotted that when it was just sitting up there. Right, so that's that type of rationalising the denominator, just when it's just a kind of simple fraction. What we're going to look at next is we're looking at how to rationalise the denominator when we've got surds in this type of form here on the denominator. So what I'm looking at is to try and rationalise these ones, I'm looking at the negative sign that's there. And what I'm going to do is I'm going to multiply top and bottom by root 2 plus 1. Okay, so I'm going to be using the kind of difference of squares type format, where I can multiply that out and I'll have a rational number on the bottom by doing that. So what I said I was going to multiply by was root 2 plus 1, and on the top it's root 2 plus 1. Okay, and these are called conjugate surds. Let's multiply these out. So on the top I've just got that there because I've got 1 times root 2 plus 1. On the bottom I'm going to multiply out using FOIL. So root 2 times root 2 should give me root 4. Outside, root 2 times 1 will give me plus root 2. Inside, minus 1 times root 2 minus root 2, and finally minus 1 times 1 will give me minus 1. And when I do this, when I multiply these out with conjugate surds, the two middle items will, the two middle terms will cancel each other out. So plus 2 root 2 minus root 2 will become 0. Right, so what I have here is, on the top, the numerator, root 2 plus 1, and on the bottom I've got root 4 minus 1. Normally what I can do here is I'll be able to work out the a final number on the bottom, because what I have there is the square root of 4 is 2. This would give me root 2 plus 1 all over 1, and quite simply that would just be root 2 plus 1 as an answer. Okay, so it's quite a lot of working for these. Multiplying by the conjugate surd, and what that would be is, if it's a negative there, I'll multiply by the positive. If it's a positive, I'll multiply it by its negative. So try and have a go and see if you can work out these 3 questions. That's the last 3 that we're going to do within this section. Okay, so let's go for it. I'm going to multiply by root 5 minus 1. Top and bottom. Okay. On the top I've got root 5 minus 1. On the bottom, root 5 times root 5 will give me root 25. I've got minus root 5 plus root 5, and then finally minus 1 when I multiply that all the way through. I've got root 5 minus 1 on the numerator, and I've got root 25 minus 1 on the denominator. This is going to work out to be a number because that's a square number. So what I'll bring out there will be a 5. 5 minus 1 should give me final answer of root 5 minus 1 all over 4. I'm going to multiply this one by 2 plus root 3. So it'll be 2 plus root 3. And 2 plus root 3 on the top. Multiplying it out using FOIL on the bottom, and on the top it will just be multiplying out using the single bracket multiplication. So I've got 12 times 2 will give me 24, and 12 times root 3 will give me a plus 12 root 3. Multiplying the bottom out, I've got a 2 there and a 2 there, so that's going to give me 4. 2 times root 3 is going to give me plus 2 root 3. On the bottom I've got minus root 3 times 2, which gives me minus 2 root 3. And minus root 3 times plus root 3, okay, that's going to give me minus root 9. And from that I'll be able to work out a rational number. On the top, 24 plus 12 root 3. Right, here we go. I've got 4 here. These two guys are going to cancel each other out, and I've got minus root 9, which is going to work out to be minus, if I take the square root of 9, is 3. My final answer is going to be 24 plus 12 root 3 all over 1, and quite simply that's going to be 24 plus 12 root 3. Okay. I can take a common factor out to try and simplify that a bit further. Okay, the final one, that we've got. So I've got 1 minus root 2 on the bottom. What I'll do with this is I'll multiply it by 1 plus root 2 and 1 plus root 2 on the top. So that's the top and the bottom. And just remember that 1 plus root 2 over 1 plus root 2 is just multiplying by 1, just the same as we've been doing all along. On the top I've got 1 plus root 2, multiply the 1's out, that'll give me 1, plus root 2, minus root 2, and finally I've got minus root 4. On the top I've got 1 plus root 2, and I've got 1 here, and these guys are going to cancel out because plus root 2 minus root 2 becomes 0, and I've got minus root 4, which is minus 2. What I have here is I've got 1 plus root 2 all over minus 1. So that could be the final answer there. If I wanted to leave it like that, I could put it there, which would be minus 1 plus root 2 all over 1. Or quite simply, what we'll have is oops, let's take that one away. So it's minus, that's going to be 1 minus root 2. Okay, so that's rationalising the denominator. Some more difficult ones towards the end. Just remember that when you multiply by the conjugate surd, what we're doing is we're multiplying out by FOIL and working through, and we're getting a rational number on the bottom. Okay, so good luck with trying the questions. Hopefully you've tried them on the way through, and you now are able to rationalise the denominator.